Hey, good morning. My name is Markus Turtinen, and I'm CEO of Visidon. Visidon is a company developing mobile facial recognition technology, and we have also been integrator partner in this MOBIO project that Sebastian described just before me. So mobile phones are quite attractive platforms for doing biometric applications. There are millions and millions of devices, and we can think about several potential use cases where it can be used. They have integrated sensors like camera and microphones. There is some processing power available for run algorithms, and they have excellent communication capabilities like wireless LAN or 3G connections. But most importantly, they offer open APIs for developers so that we can use these resources and use these devices to run our own algorithms and applications and create new scenarios. But it is not so easy to bring this technology for traditional mobile phones, and there are a lot of challenges. And in this talk, I will shortly summarize the challenges that we have faced when doing this integration into mobiles. So I have categorized these challenges into two categories. First is the technical limitations, which deals issues like sensor quality and processing power limitations, and second is the use case limitations, which means the user convenience and usability issues, and finding out the most potential applications where these kind of technologies can be used in mobile environments. Okay, about sensors, you know that mobile phones are targeted to mass markets, meaning that there's probably $1 camera sensor used in the devices, and this definitely has some effects on the image quality. And for example, the frontal faced camera, that is the most obvious sensor to do facial recognition, because it is faced towards the user, is typically very low cost and has quite poor image quality in low light conditions. Also, the audio sensor in the mobiles are optimized for mobile communication and not for biometric. So all these limitations affect to the data quality, and actually there is not too much that we can do to improve this data quality. If the information is missing, it's very hard to bring it back. So the most important thing is to concentrate on algorithms and make them to tolerate these kind of situations, and make them handle more efficiently to poor quality data. Secondly, as Sebastian already pointed out, even the modern mobile devices are still very far from desktop or server hardware. If we take for example the latest iPhone, it has 1 GHz processor and half a gigabyte memory available. So, and if we compare it to the commodity PC hardware, we can see that it's probably like 10 years old PC. So there is a huge difference from this point of view. But for these, there is a little bit more that we can do to tackle this problem, and the main things are related to software optimization and algorithm level optimizations, and also those embedded processors that are used in mobiles usually provide some extended instruction set that can be used to boost out these software implementations, and also there are usually some kind of co-processor available on the devices that can also be used for boosting the performance. But in these both cases, we usually lose the portability a little bit, because then it's specifically implemented for some specific platform. In some cases, it's also possible to distribute the computational load between the mobile and remote server. And in these kind of scenarios, most of the processing can be made somewhere else than in a mobile. Mobile is used for data acquisition and doing some pre-processing, for example. And one important thing in the mobile is, of course, battery. They are portable devices, and they run multiple programs. You can do imaging, you can browse internet, you can use map applications, and all these fancy applications utilizes the limited resources of the mobile. And we have to share these resources with other applications. So they are not dedicated to biometric. And especially in a biometric application where we start different sensors like camera and microphone and use the application processor at full speed, it typically takes a lot of battery. And one thing that developer can do is of course to design these applications and user interface in a mobile efficient way, and avoid doing some fancy effects with the screen and the sensors. And if you go to the use case challenges, we have to realize that these facts like data quality caused by sensors, for example, and limited processing power, and typically totally uncontrolled environments, meaning that the mobiles can be used anywhere, sets limits to possible use cases. And we have considered two different scenarios. In the embedded case, all the processing is made on the device, and in a client-server case, the mobile terminal is used for data acquisition, and the actual processing is made on the remote server. In this embedded scenario, we created application that can be used to access to your favorite web services like Facebook, Twitter, or your email accounts like Gmail, using your face and voice recognition. And the main challenge here is to make this app fast enough so that it doesn't disturb user, but it is convenience for user to use. So it has to be robust enough and fast enough. And if we consider the facts that mobiles can be used in different illumination conditions, it is quite a challenge to make it to work so that the user doesn't feel uncomfortable to use this application, but it actually helps user to access these services faster way, and of course increase the security a little bit, because no passwords needed to be stored on the memory of the device. In the second case, we have a little bit more resources to do the actual data processing because it's done on the remote server. But the mobile is used for data acquisition, and still the data quality is what is it. So the same sensors are used for acquisition, and this raw data is transferred to the server. And of course, more data we get, more data we collect, usually make the verification a little bit more robust. But there is a trade-off of usability and data transferring. So typically, user doesn't want to spend too much time to access some services or confidential data, but that we have to do some kind of balancing. And of course, it adds latency if we collect data for several tens of seconds and then send it to the server, wait for response. So this is also about user convenience, because typically the mobile users want that these applications are very easy and robust to use. To conclude these technical challenges, I can say that the main limitations are still in processing power and data quality. This is because of low-cost commodity hardware, and it has effects on the data. But also, it's very big challenge to design the most usable scenarios where the mobile device and mobile biometry really brings the advance to the users. So this is one issue. These applications need to be convenient for user, and main thing to bringing these algorithms is of course to put bringing these algorithms to mobile is to put more effort on designing them to be extremely robust for uncontrolled environments, because we usually cannot control people too much, so that this application can only be used for some specific place, but mobiles are used everywhere. Okay, thanks.